Now here we see a method to check whether a given function is onto or into. So here the procedure is very much similar to the one which we followed to find out the range of the function. So to begin with, we consider that y is equal to the given expression of the function. So we say y equal to f of x. Then next we rearrange the above equation and write it in the form as x as some function of y. Say x is equal to g of y. And now if for every value of y in the given codomain of the function, if x exists in the domain, that is in the first set of the function, then the function is of type onto. Otherwise it is of the type into. Okay, so let us see some of the examples based on this particular type. Now while solving, we have to also note the terminology. Sometimes the different wordings are used, that is the onto function is also called as a surjective function or a surjection. Okay, the one function is called as the injective function or an injection. And lastly, if sometimes a function can be of both of the types simultaneously, that is one as well as onto, then that function is called as a bijective function or simply a bijection. Okay, so now let us see the actual question. Find whether the function f defined from reals to reals and given by the expression f of x equal to 3x plus 2 whole divided by 4 is onto or into, right? So let's begin with calling the function as say y. So therefore here we have y is equal to 3x plus 2 whole divided by 4. So now we know that we have to rearrange this and write it as x in terms of y. So therefore we have 4y equal to 3x plus 2, which gives us 3x as nothing but 4y minus 2. Therefore finally we get x is equal to 4y minus 2 whole upon 3, right? So now based on this final equation, we have to decide whether the function is onto or into. Now let us revisit the original concept of onto. That means we are given that the function is defined from reals to real. So the first set is a real and the second set is also the set of real numbers. And in general we denote any element in the first set as x and its corresponding image in the second element as y. So when x goes as an input to f, we get the corresponding value y. Now what we have done essentially is we have written down an expression which expresses x in terms of y, right? So we have done a kind of reverse mapping, and now we have to check, that is, since y is nothing but a real number, if the function is supposed to be onto, and by the onto we mean that each and every value contained in the second set, that is nothing but real numbers, it has some or the other pre-image in the first set. So in other words, we want to see if are we able to get any value in the set of real numbers for which x does not exist. If it is the case, then the function will not be an onto function, it will be an into function. But if for every value in the second set, that is nothing but for every real value of y, if we always get some real value of x, then it means the function is definitely an onto function. So now let's look at the expression here. We see that y is in the numerator, right? The denominator is 3, so here we don't have any problem. The denominator is never going to be 0. Now if y is a real number, then we know that 4y minus 2 will also be a real number, and that divided by 3 will also be a real number. So that means for every real number in the second set, you can also always find the corresponding real value of x in the first set. Or in other words, there is no number, there is no real value in the second set where corresponding pre-image in the first set does not exist. So therefore, it's clear that the given function is of the type onto. It covers the second set completely, right? Now let's see one more question. Find whether the following function is onto or into, where the function is given as x square minus 4 upon x square plus 1. And here also the function is defined from reals to reals, right? Now let us start by saying y is equal to f of x, which gives us y is equal to x square minus 4 upon x square plus 1. So on cross multiplying, we will have yx square plus y is equal to x square minus 4. So let's bring x square terms on one side. So you will have yx square minus x square is equal to minus y minus 4. So taking x square common, here we have y minus 1 is equal to minus y minus 4. So therefore x square is equal to minus y minus 4 whole upon y minus 1, and hence finally we get x square is equal to, suppose we want to just invert both the expressions, we will have y plus 4 upon 1 minus y. Alright, so changing the signs of both numerator and denominator, we get this. So therefore finally x is nothing but square root of y plus 4 upon 1 minus y. Now based on this, now we have to once again decide whether the function is onto or into. If we relook at the two sets, it is from real to real. Now as we have seen, we have to find out whether for every real value in the second set do we get a corresponding real value of x. Sometimes it is very easy to produce some counter example which contradicts the fact that we are trying to prove. Now here we observe that the denominator is 1 minus y, and we know that in any expression the denominator can never be 0. So here if we think that y is equal to 1, then in that case x will not exist, because the entire right hand side will have no meaning if y is equal to 1, because it will make the denominator 0. So that means the value 1 of y will not have any value of x in the first set. So that means the all values of real numbers in the second set are not present in this particular mapping. So therefore the function is definitely not an onto function, hence it is an into function. So this is the answer, that the function is into.